All right, we've been talking about how dark matter was first discovered. Now let's talk about the properties of dark matter. What is it? This is this weird stuff, and I know you've heard about dark matter on TV, etc. First off, it's difficult to see, hence it's got the name dark. It's called dark matter, sort of like in the ancient times, Africa was called the dark continent, mostly because it was unknown. People did not know what the interior looked like. It hadn't been mapped. People hadn't visited it as far as the Western world is concerned. Dark matter is very similar. We don't really understand it. And so we've given it the name dark to indicate that we humans are in the dark and are quite ignorant. Dark matter exerts a force of gravity. Dark matter actually pulls on other matter. And it can be 80 to 90% of the mass of a galaxy. That's one of the things that Vera Rubin and her colleagues showed. And so 80 to 90% of the mass of a galaxy is something we can't see and don't really know what it is. That makes it a wonderful, wonderful mystery. So modern science is trying to determine exactly what is dark matter. One hypothesis is that it is matter that we just cannot see. So one quest is it might be dead, burnt out stars, black dwarfs. Once a star has given up all of its heat and fuel, it's going to be a little cinder that's just floating around in the cosmos. It's kind of like looking for a lump of coal on a moonless night in the dark. It's going to be hard to see. So that's one hypothesis. Black holes, not all of them are in the center of galaxies. We think it's essential for a galaxy to have a black hole at the center, but we don't think all black holes are there. So maybe there are black holes that are kind of like rogue black holes wandering around the cosmos, but they contain a massive amount of mass. That might be where some of the dark or unseen matter is. The other option is super Jupiter kind of planets. Big, big, big planets. They're not massive enough to actually glow. They're not massive enough for fusion to occur, but they can occupy an awful lot of the mass of a solar system. And the last hypothesis is something which is called a neutrino. And we'll talk more about neutrinos in a bit. They're a little subatomic particle. How do we know dark matter actually even exists? I mean, if you can't see it and it's hard to see, are they just making this stuff up? Well, one of the weird and crazy things, because of the fact that gravity will cause the fabric of space and time to bend, is the fact that gravity will cause light to actually bend. And this is one of the big ways that we detect dark matter. Let's say that from our position on Earth, looking back at a cluster of other galaxies a long, long way away, we know from our changing position around the sun that there is a galaxy way over here that we have a better view of at some places than others. The weird and crazy thing is, if this galaxy that is a long way away is hiding behind a huge, massive cluster of galaxies, this cluster of galaxies acts like a lens. And the light from this distant galaxy that should go right over our heads and never hit the Earth, and if a light doesn't hit us, we can't see it, and any other light that goes well below the Earth and we're never going to see it, maybe the light is going to be lensed or focused by the huge gravitational effect of a massive collection of galaxies and stars, so that we see this distant galaxy, especially when we have no business seeing it whatsoever, unless something very huge and very massive is bending the light. And the things that are bending the light, the visible matter, is not enough to account for the amount of gravitational lensing that we see. This is a real picture of gravitational lensing, where you actually see it's kind of a circular pattern. See this star that looks like it's kind of smeared out? This is light that is being seen from behind a big cluster of galaxies, and some of that starlight gets smeared out, so it sort of looks like I don't know, a dribble of syrup on pancakes as it goes around that edge. So there is observational proof that there are big gravitational features out there that are bending light. What actually is making up these black holes can be things that are called Machos. Now, Machos stands for Massive Compact Halo Object. That's what we mean by a Macho. Because of the fact that most of the dark matter that's been detected is in the galactic halo, this is the area around the outside of the galaxy, it is hypothesized that there are big, massive objects that exist in that halo. What could these be? Some of them are going to be made of normal matter. When I say normal matter, I mean protons, neutrons, electrons, the same particles that make up you and I. And some of them are going to be normal stuff, like black dwarfs, black holes, and fluffy Jupiters or super Jupiters. This would account for about 10 to 20% of the mass of a galaxy. This doesn't account for the huge amount of mass that we actually measure that must be there because of black holes. So Machos could contribute. They could be part of what makes up dark matter, but we don't believe that is the only thing that makes up dark matter. One of the other things that might make up dark matter are little subatomic particles that are called neutrinos. This is the eminent physicist named Enrico Fermi, and Enrico Fermi was an Italian physicist. He escaped from Nazi Germany and the fascist state in Italy at the time of World War II, came and worked in the United States. Fermi is famous because he and his team were the first ones to actually produce a nuclear chain reaction. Now, when they created the very first nuclear chain reaction, he actually detected little particles that were produced by this nuclear reaction that were very, very small, very, very small, and they had no charge. They were not positive like protons. They were not negative like electrons. They were neutral like neutrons. And Fermi, in his charming Italian way, called them little neutral ones, and he named them neutrinos, kind of like a small Italian baby might be bambino. These are neutrino, and so it has kind of a cute name. Part of the overall mass of dark matter might be due to neutrinos. These are normal matter. Normal meaning we see these in everyday laboratory experiments. You and I aren't going to see neutrinos. They're too small. They're too elusive. But scientists see them all the time. This picture right here is actually a picture of a particle accelerator where they jam particles together at near the speed of light, and then each one of these little curlicues and each one of these little streaks is due to the subatomic particles that kind of whiz out of this collision. In those tracks, we can see neutrinos, but you and I don't see them sitting in your room right now. Neutrinos are dark in the fact that they are hard to see, but there aren't that many of them. They could account for about 10% of the dark matter we see. The challenge with neutrinos is they are hot. Now, when we say hot, hot equates to fast. Things that move slow have a tendency to be cold. Things that move fast have a tendency to be very hot. So most of the neutrinos that are out in space are moving so quickly that they just do not have the same properties as dark matter. We don't quite have this answer yet, and the other possible choice of what might make up dark matter are things that are called WIMPs, and we're going to come back and talk about them next.